Yeah, just show up with a Browns jersey on and they'll let you in. All right, guys. So on, I think it was Thursday, we finished with this. Or we got up to this point. And I told you that the shortcut for finding the vertex of a quadratic is this idea here. You can use that formula, x equals the opposite b over 2x. I want to show you why we can use that. Okay, now it's going to take some kind of analytical algebra here where we're just using variables and no numerical quantities. Some numbers will show up through the process. Starting with ax squared plus bx plus c, I want to show you how this thing kind of generates, okay? How we can use that as simply a tool for us to find the x-coordinate of our vertex, okay? And once we have that, we should be able to use that as an input value to find the y value of our vertex, okay? So, and that's what they're saying right here, is that once you have the x value, plug it into f, okay? And you should be able to find your y value, your maximum or your minimum, okay? Depending on what the a was out in front. So, we're going to start with f of x equals ax squared plus bx plus c. And we're going to go through the process that we go through, because we're going to try to put this, in this format here. Okay? We're going to try to put it in that format there. And that format has h and k. It has completely new variables. So there's going to be at some point throughout this process what we call a redefining or redefinition of some stuff. Okay, I won't explain what that stuff is here in a moment, but we'll see that as it kind of develops. But how do we go if we had specific values for A, B, and C? How we went through and changed that to vertex form is through completing the square, right? So if we do the same thing here with ax squared plus bx plus c, maybe we generate what we want. Okay, so let's start with f of x. And I'm actually going to divide everything. So start with that up there. Okay, and I'm going to divide everything by a. If I divide everything by a, f of x gets divided. Ax squared gets divided. Bx gets divided. And c gets divided. You guys agree with that? And we did everything that we're going to do right now. We did about 6 or 7 weeks ago when we first started talking about a quadratic formula and developing it. But when we're done, we won't go as far in this as we did with the quadratic formula. The next step was to move the c over a over. Move my constant to the other side. So I have f of x over a minus c over a is equal to x squared plus b over a times x, right? Okay. And now, to kind of draw in a comparison to what maybe we saw last week. Last week, maybe we saw this as like an x squared plus 6x. I just said using kind of specific values. If that was x squared plus 6x, the next step was to take half of 6, right? Okay. Well, now we're going to take half of b over a. Okay, so half of b over a would be look like b over 2a, right? Does that make sense? And then we're going to square that, because that's what we would do to that 3. We square 3 and get 9. So now we'll take b over 2a and we'll square that, and it's going to give me b squared over 4a squared. Okay, is that okay with everybody? So taking half that middle term, b over a, and squaring it. So if I add it to the right-hand side, we only need to do the left-hand side. Okay, I need to add that over here as well, right? I got to keep this thing balanced. Now, why do we do that? The hope was that we are able to generate right here a perfect trinomial. And that thing is now a perfect trinomial. And it's going to look like this. X plus, now what goes right here, so this plus sign is always what that plus sign was, or if it's a minus, the minus. But what goes in that second spot of this binomial is half of that middle term. Okay? So if it was x squared plus 6x, what goes in that second spot would just be 3, right? Here, because we're using the arbitrary value of b over a, half of that goes right there. Square that. And over here we still have b squared over 4a squared plus f of x over a minus c over a. Okay. What can I do? So remember, what we're trying to do is try to rewrite f of x. So once I've done this, I now need to try to get f of x by itself. If I'm trying to get f of x by itself, I basically need to subtract that from both sides and add that to both sides. Okay, so we'll do that. So we'll have f of x over a is equal to now x plus b over 2a squared. I'll be plus c over a minus b squared over 4a squared, right? Does that make sense? Now I'm trying to solve for f of x, so what do I need to do now? How do I get f of x right here all by itself? Multiply by a. So multiply that by a, that by a, that by a, that by a, right? Multiply every single term by a. So it gives me f of x. This is going to be a times x plus b over 2a squared. This is going to be plus c minus then b squared over 4a. Is that okay with everybody? And that right there is vertex form. Okay? But it doesn't look like the h and k vertex form, right? Because what we do then, this is where I talk about redefining terms. We call that thing, because it's a combination of some stuff, it's easier to talk about it as this new variable h. This garbage here, easier to talk about as the new variable k. So now we have f of x is equal to a x plus h squared plus k. That's a more concise way of writing it, right? But what are we seeing here? That term right there, b over 2a, is at h, correct? Okay. Now, when we see it inside our vertex form, we see a times x plus h squared plus k. Okay. We know that because we're adding or subtracting to an x, it's actually moving it the opposite direction of what we do, right? If it's adding, we move it left. If it's subtracting, we move it right. So when it's x plus b over 2a, the idea is that the vertex is moving kind of contradictory to that positive number, right? Or that plus sign. So if this is b over 2a, whatever that number is, the opposite of it, that negative, needs to be incorporated so I know the location of the vertex is x coordinates. That kind of makes sense, everybody? So now we know why that x equals opposite b over 2a works, why that gives me the vertex every single time. Okay? Now, if I want the y value of my vertex, I can just take that function value, opposite b over 2a, and plug it in as an input, see what the output is. The output then, whatever that number is, positive or negative, I'll analyze. If the a number was positive, it would be a minimum. If the a value was negative, it would be a maximum. Okay? What happens, though, is when you plug it in, you're going to get that thing right there. It would be equivalent to c minus b squared over 4a. Okay? Back when we were doing this earlier in the year, somebody actually came up to me, and they figured this out on their own, kind of figuring out kind of a shortcut for finding that ordered pair, that y value of that ordered pair. So this is kind of a nice tool, because now maybe it's a workaround, a little bit of a workaround, to go from maybe one of these versions to vertex form. Instead of completing the square now, maybe we can do this. Okay? If I want to change this thing to vertex form, I know it's going to be in the form of some a, x, plus or minus some number, plus some k, right? Okay. Well, how can I determine this? Well, I want to find x, so I'm doing option B here. Problem B, x equals opposite b over 2x. What's opposite of b going to be? Negative 4. 2a would be negative 4, right? So 1. Okay. So my x coordinate of my vertex is at 1, at positive 1. So in this, it would be negative 1, right? Does that make sense, everybody? okay, because of the way the transformations work. Now I've got to figure out what this y value is going to be. Okay. Well, my y value, okay, is when I evaluate this function at 1, isn't it? Okay, so I'm going to get negative 2 plus 4 minus 5. Okay, so they give me negative 3. So my y value is negative 3. Now here's the thing. I need this a. If I were to FOIL all this out, guys, I'm going to get x squared minus 2x plus 1 minus 3, right? That a right there, if I FOIL out, is 1. What does it need to be? Negative 2. So how do I get that to be a negative 1? Multiply by negative 2. Sorry, I get to become a negative 2 from a 1. I multiply by negative 2, right? So isn't that a value the same as this one right here? All right. So now if you expand that right there, it gets you back to that. Okay. And I think that it is really the same as completing the square. So hopefully you understand that. But I think it's just a shorter way of doing it. Okay. Not going through add 5 to both sides, divide everything by negative 2, and then halving and squaring and that kind of stuff. But the opposite of b over 2a, that itself was found by completing the square, right? Does that make sense? So that's kind of the benefit. My plan for today was actually to get into 3-2, but we're not going to have time for it. So I do want to talk about this a little bit in more detail than what we were going to at the onset of class. It's called modeling with quadratic functions. We've modeled already with these things. You guys remember doing the projectile? Okay, the negative 1/2 t squared plus v sub naught t plus h sub naught. Okay, those are modeling situations where we're taking a real life situation and explaining it with a quadratic equation. Okay, a quadratic function. There's a lot of real world phenomena that can be modeled using this, and one of them is gas mileage. Okay. Hopefully you all understand or realize that if I have a car and I'm going like 110 miles per hour, I'm going to go through gas pretty quickly. Okay. Now I might get far, okay, but I'm going to go through gas real quick, so my miles per gallon is very low. Okay. If I'm going like 2 miles an hour, okay, I'm not going to get far, and I'm going to use a lot of gas, so my miles per gallon is pretty low again, right? Does that make sense? Okay. My best miles per gallon, which is something that we're interested in, right? Especially as gas prices increase, we want good miles per gallon. Okay. About 10, 12 years ago, gas was like $4.50 a gallon. People were all selling off like SUVs and trucks and that kind of stuff, buying Priuses and all that kind of stuff. The hybrids all came into play because miles per gallon became a very, very important thing to consumers. So they want to spend $5 on a gallon of gas. That time I had an SUV and it would seriously cost me like $80 to fill it up. It's ridiculous. The function up there is modeling the particular gas mileage for some car. Okay, and we want to know at what speed do we attain the best gas mileage. Okay, and this might be, I'm not 100% sure. I'm gonna see if I can go on YouTube and find some of these. You guys watch commercials, right? And there's always, every time that a commercial break comes on, there's at least one car commercial every commercial break. Okay, it's ridiculous. But at the end of the commercial, when they're telling you the price, and they put the highway miles per gallon and the city mile per gallon on there. At the bottom, there's like a huge long paragraph that's in really tiny white print. I would venture to say that if you took a magnifying glass out and you looked at that tiny print, at somewhere on there it's going to say, even though the highway miles per gallon was 42 miles per gallon, is because we were traveling at a speed of 41 miles per hour. Anybody travel 40 miles an hour on I-75? No, okay, you're going to get in an accident, right? It's not safe. But that's the idea. That's what they're showing you. They're going to show you the miles per gallon when they're going 80 or 90, okay, because they're going to be low. All right, they're going to use the statistics to market to you. I like this big number of 40 miles per gallon. I'm going to buy that car. Okay, people were doing it all the time 10, 15 years ago. Okay, So what's going on here, and this is something I think we need to understand with notation, we don't have X's and Y's anymore, right? We have S's and M's of S's, or M of S's. We have to understand what is our dependent and what is our independent variable. Independent is the horizontal axis, right? What is independent up there? Is speed independent or is miles per gallon independent? Which one impacts the other one? Speed impacts miles per gallon, right? So speed is your independent. Okay? Miles per gallon, or M of S, is your dependent variable. So here's the idea. We want to know what speed would you reach the largest, essentially, Y value right here, right? Make sense? That would be a maximum, right? This thing's concave down because that's negative. It's parabolic. So does that kind of shape kind of make sense to us? Okay. Now, just because I at the beginning, whenever I created this, I don't know how many years ago I created this, I believe if you plug in 15 or 70, you start to get negative Y values back. Okay. So I'm just saying this car has to travel at least those two speeds for this function. Okay. Or between those two speeds. Now here's how we figure this out. At what speed do I need to be going? Well, the vertex is that point, right? Don't we know the vertex, I'm going to say X instead of X, is equal to opposite B over 2A. Does that make sense to everybody? Okay. So can I take the opposite B, which would be negative 3, over 2 times A, which would be negative 128. This would be negative 3 over negative 114. What's negative 3 times negative 14? 42. So it tells me that S coordinate is 42. Okay? Now, the maximum, the Y value, would be this function evaluated at 42, right? So let's take this function and I'll evaluate negative 128 times 42 squared plus 3 times 42 minus 31. I just plug that in. Okay. And that should give me 32. So at 42 miles per hour, if I travel at that rate, that constant rate, we should get 32 miles for every gallon of gas that I use. Does that make sense? Okay. 10, 15 years ago, a lot of your SUVs and trucks and stuff like that got like 12 miles per gallon, 13 miles per gallon. Okay. So you're spending $5 for every time that you go 12 miles. That's kind of ridiculous, right? Pretty expensive. That's why we had kind of a sell-off of those things back when gas was real expensive. So now, my question, and we're kind of running out of time for this, is where does that thing come from? Okay, because I can find the information, the 42, 32, that's awesome, it's great. But if I'm in real life and I want to know how to do this, I need that, right? Somebody has to give me that. Well, how do we find that? Anybody know? Do you guys remember in chemistry, maybe the first lab you did, you took boiling water off of a Bunsen burner, and you took a thermometer at 1 minute, and you measured the temperature, and then at 2 minutes, you measured the temperature, and at 3 minutes, you measured the temperature, and 4 minutes, you measured the temperature. Remember doing that kind of thing? And then you found, okay, let's find a line that models that data the best. Maybe that's that line right there. And you use two order pairs that were on that line to create it, right? Create the equation. Okay? That was the line of best fit, right? That's what we called that. Same thing happens with parabolas. Okay? We can model basically putting our car, putting some gas in our gas tank. Now we want to make sure we know how much we're using because we're going to do this over and over and over again. So we want to make sure we're using 5 gallons every single time or 20 gallons every single time or whatever. And then we start traveling at a certain speed. And we see how far we get. And we start collecting these data points. And now all these are data points that we collect doing this. What do you notice about those? What kind of shape do they make? They're parabolic, right? So what we find is that we can make what's called a least square regression. You guys remember talking about that in Algebra 2? Okay, I know you use your calculators to type this data in, and it will provide you the parabola. Okay? This is the process for coming up with that equation that I had at the beginning. Does that make sense? So places like Honda, Ford, all your car manufacturers, they will do this. They will take every single type of car they develop, and they will run it through a bunch of tests, okay, traveling to determine the gas mileage. Okay? And they're very, very precise about it. They're very, very science-oriented about it because it's one of their major selling points. Okay? A lot of people will buy a car solely because of that. Hey, 3.1 is open, due on Wednesday.